Our next two functions are rational and cubic. So again, drawing our parent functions to start with. With the rational, I didn't need you to memorize too many points. The main ones we're looking for is -1, -1, and then the fact that 0 has an error, and then the point 1, 1. Remember that we have that error at 0 because you have a vertical and a horizontal asymptote. Those points are at x equals 0 and at y equals 0. So I'm going to sketch this with my pencil. We have these fake dotted lines here that our graph is never going to cross that happen to be right on the x and y axis for our parent function. Other than that, our points, here's 1, 1, and that creates this half of the graph. And then here's -1, -1, and it creates this half of the graph. Those are going to continue on infinitely, getting closer and closer to those axes. Our domain here is actually all real numbers except x does not equal 0. And our range is all real numbers except y does not equal 0. Again, those are because of those asymptotes, it's never going to cross there. Our cubic function is a little more straightforward. Again, we use the same points, -2, -1, 0, 1, and 2. If you cube a -2, you're going to get a -8, -1, 0, 1, and 8. Plotting those points here, 0, 0, 1, 1, 2, 8, -1, -1, -2, -8. Creates this little curved graph. Be sure I can kind of see a little curve in there. It doesn't have to be out of control, but be sure I can tell the difference between this and a straight line. Domain for this one, all real numbers. Range, also all real numbers. So again, we've done a couple transformations by now. You should be able to tell what the effect on the graph is going to be. This is a rational function. The +3 is outside of the equation. This is an up 3. -2 inside with the x is going to be a right 2. Negative, as always, reflect. +2 inside the function, left 2, -3 outside, down 3. So the tricky thing is be sure you can tell the difference between inside and outside. For our cubic, 2 in front, you know is going to be a stretch, specifically a vertical stretch. +3 on the inside. These look very similar to the quadratic. That's going to be a left 3. -3 on the inside is going to be a right 3. +1 on the outside, up 1. Negative, reflect. -5, down 5. Back to a rational function. Negative, reflect. +3 outside, up 3. +2 inside, left 2. -3 outside, down 3. 14, reflect. And down 5. Inside, left 3. Let's go back and actually graph these last 4 examples. So, first one is a rational function that has been reflected and moved up 3. So I'm going to start with a pencil or a different color because if you remember our first point, 0, 0, is not actually on the graph. It just creates that point that where our two asymptotes intersect. So usually that point is at 0, 0, but if I've moved up 3, that point is now going to be right here. This is our new fake origin, but it's not a point that's actually on our graph. From here, I'm going to sketch our two asymptotes. Going this way, and this way, and this way, and this way. Okay. From there, typically my point, remember if this is my new 0, 0, my point is usually 1, 1. But this graph has been reflected. That's going to move the point 1, 1 down here and going to create this half of my graph. Usually our other point is at -1, -1, but again, it's been reflected, so it's going to be up here and create the other side. This page didn't specifically ask for it, but let's talk about our domain and our range. And just for kicks, let's also talk about the vertical asymptote and the horizontal asymptote. Looking at this graph, remember the vertical line we drew right here, is still at x equals 0. Our the horizontal line we did right here, has been moved up 3, so it's at y equals 3. Those points help when you're writing down your domain and range, because your domain is all real numbers except x cannot equal that vertical asymptote point. For the range, same thing, all real numbers except y cannot equal the horizontal asymptote. Similar thing on number 13. We said that it moves left 2 and down 3. So again, I'm going to start with a different color, 0, 0. If I move left 2 and down 3, that's my new 0, 0. That creates these like crosshairs of where our two asymptotes intersect. Since I'm going to identify them anyway, I'm going to go ahead and write these down. Vertical asymptote is usually at 0, 0, but we've moved to the left 2. That puts our asymptote at x equals a -2. For the horizontal, again, it was usually at 0, 0. We moved down 3, so y equals -3. For the rest of our graph, remember the point is usually at 1, 1. Again, we haven't stretched, which we're not going to stretch rational functions this year, and we haven't reflected, so that point is still right there, and I can draw the rest of my graph. Same thing for -1, -1. Domain, all real numbers except x cannot equal -2. Range, all real numbers except y cannot equal -3. Okay. Be sure when you're graphing these that I can tell that your graph is not crossing those asymptotes that you've drawn. Looking at our cubic example, this one has been reflected and moved down 5. So again, usually it's 0, 0, but I'm going to move it down 1, 2, 3, 4, 5, put a dot. If you remember your cubic table, I'm going to go ahead and write it down for you. -2, -1, 0, 1, and 2. -8, -1, 0, 1, and 8. So if this is my new 0, 0 point, it has been reflected, so all of these numbers are going to multiply by a -1, making it an 8, 1, 0, -1, -8. So my point from here, my new 0, 0 point is usually 1, 1, but I have reflected, so it's 1, -1. Then to -8, which is going to take it off this paper, so I'm not going to sketch that point. -1 is now at 1. -2 is now at 8. I could complete my graph from here. The other thing to be sure about graphing cubics is if we had done our 3 point, 3 cubed is 27. So be sure when you're sketching these, you don't start coming way out here because those points aren't on your graph. After this 8 point, it pretty much goes almost straight up because your line is so steep because it's trying to get to your next point. Same thing on our next graph. Same equation, but I'm moving it left 3. So I go left 1, 2, 3, put a dot. From there, I can sketch my normal points because it hasn't been transformed. So 1, 1, 1, 2, 8. Lost count. -1, -1, -2, -8. That nice curved shape. Domain and range on both of these graphs is still all real numbers. Looking at the next page. They tell you how to transform your equation, and you need to write your new graph. So starting with a rational, I'm going to go 3 units to the right, 5 units down, and reflect. So my equation, y equals, I need a negative. 1 over, because it's rational, 3 units right needs to go down here with the x, and that's a minus 3. 5 units down is a minus 5 here on the outside. Be sure I can tell the difference between numbers that are inside and numbers that are outside. Starting with a cubic graph, we're going to reflect it, stretch it, and go left 2. Y equals reflect, stretch. In parentheses, because it's going to the left, x plus 2, need my little 3, so I know that this is a cubic graph. Again, starting with a cubic, we're going to shrink it by a factor of 0.5 and go up 2. Y equals, I need that 0.5 in front to shrink it. I don't need parentheses this time because nothing is moving to the left or the right, so I could go ahead and just put my x cubed. Up 2 is a plus 2 on the outside. Starting with our rational again, we're going to go left 6 and down 1. So y equals 1 over x because it's a rational, left 6 plus 6 underneath the line, down 1 minus 1 on the outside. Again, be sure I can tell the difference between what's inside and what's outside. Starting with a rational, reflect and go right 4. Y equals negative for the reflection, 1 over for the rational. Right is going to be on the inside, minus 4. Last one here, taking our cubic graph, right 3 and up 4. Y equals, I need parentheses because it's going to the right, minus 3 cubed, up 4, plus 4. How can you find the equation from the graph? So sometimes on these rational ones especially, it's a little tricky. It might help to find this line where your asymptotes are. They're not going to be sketched for you. You have to find them. So this point right here is my new 0, 0 point. It looks like my graph has moved to the right 1, 2, 3, right 3, and up 1, 2, 3, 4. I can write my equation from here. Y equals, again, it hasn't been reflected because it's still 1, 1, and negative 1, negative 1. So y equals 1 over, because it's a rational, x minus 3 inside, for the right 3, plus 4 on the outside. Same thing with this next one. It's another rational. I really do think it helps. Find these lines and follow them until you can find those points where that new 0, 0 is, right here. This graph has moved to the left, 1, 2, 3, 4, 5, 6, 7, and up 3. It hasn't been reflected because, again, we're at 1, 1, negative 1, negative 1. So my equation is a rational. 1 over, left 7 goes inside as a plus 7. Up 3 goes outside as a plus 3. The cubics are a little bit easier. Again, I could tell it's a cubic from the shape of the graph. This point is your new 0, 0. It looks like we have moved to the left 1, 2, 3, and up 2. This graph has also been reflected because our normal point is at 1, 1. And I can check this. It's 1, negative 1. That's a reflection. Y equals negative for the reflection, and x plus 3 for the left 3, cubed for the type of graph it is, and up 2 is a plus 2. The last one here. Here's our new 0, 0 point. We have moved to the right 1, 2, 3, 4, and up 2. No reflection, no stretch. Our next point is still 1, 1 away. So y equals no negative, x minus 4 cubed plus 2.